Hello and welcome to Otten Math. In this edition of Otten Math, we're going to solve some practice problems involving solving rational equations. Right, so let's get started. First two questions, we're asked to solve the equation by cross multiplying. So remember, that's our first method that we learned in the lesson. So when we cross multiply, we're going to multiply the numerator by the denominator of the numerator of the first value times the denominator of the second fraction. So I end up with 4x squared is equal to 4, denominator of the first times the numerator of the second is equal to 36. I divide both sides by 4. I have x squared is equal to 9. I take the square root of x squared and the square root of 9. And remember, when I take the square root of a squared value, I have to add plus or minus to the right-hand side of the equation. So I have x is equal to plus or minus the square root of 9, or x is equal to plus or minus 3. I check both plus or minus 3 back into the value for x by substituting that value in for x, and I find that negative 3/4 is the same as 9 over negative 12. 3/4 is the same as positive 9 over 12. So I have no extraneous solutions. Second problem, again, I multiply the numerator of the first times the denominator of the second. I have x squared plus 2x is equal to 2x times 2x plus 1, or 4x squared plus 2x. I subtract 2x from both sides. I'm left with 0 there. I have x squared is equal to 4x squared. Now the only, in this case, if I were to subtract 4x squared, actually subtract x squared from 4x squared, I'd have 0 is equal to 3x squared. And the only value of x that makes this particular equation true is going to be 0. Now 0 can be a result, because if I put in 0 for x in the denominator in the first rational expression, or the rational expression on the left-hand side of the equation, I get positive 1. And if I put it into the denominator of the second rational expression, or the rational expression on the right-hand side of the equation, I get plus 2. So the only criteria now is that the denominator of either term cannot be equal to 0. And if I have 0 as a solution, it works out that I have a positive value for both the denominators in both rational expressions. So 0 is going to be my answer. Right, solve the equation by finding the lowest common denominator. In this case, as I look through this problem number 3, I look through each of the terms, I see that my lowest common denominator, I can write 1 over 1 and 2 over 1, is going to be x. So now I'm going to solve the equation by multiplying all the terms by x. So 9x times x, so 9 over x times x over 1 gives me 9. And then negative 1 times x gives me negative x. So my common denominator is equal to x. I multiply each of the terms by x. 9 over x times x is x. I'm sorry, 9 over x. 9 over x times x is equal to 9. Minus 1 times x is minus x, or negative x. Now I multiply 3 over x times x, I get 3. And plus 2 times x gives me plus 2x. I add x to both sides, I have 3x. I subtract 3 from both sides, gives me 6. I'm left with x is equal to 2, and that's my solution. Right, problem number 4, I see that the common denominator here is x times x minus 4. I'm going to multiply x times x minus 4 over 1 by all the terms. So let's take the first term first on the left-hand side, x over x minus 4. And I see a common factor of x minus 4, which leaves me with x squared. So common factor of x minus 4 reduces to 1. I just have x times x over 1, or x squared. So let's erase this first term, and we're going to multiply our common factor times the second term, or negative 4x. Common factor again of x and x. I'm left with negative 4x plus 16. So negative 4x plus 16. So again, x and x are common factors, so I'm left with negative 4 times x minus 4, which is negative 4x plus 16, is equal to, and again I multiply my common denominator times all the terms. This is my last term, 3 over x minus 4. X minus 4 is a common factor, reduces to 1, so I'm left with 3 times x, or 3x. I can simplify or rewrite this particular equation using my zero product property. So I want to set the right-hand side equal to 0 by subtracting 3x. I get x squared minus 7x plus 16. Now I have to find the common factors, or the factors of 16 that add to negative 7. I have 1, 16, 2, and 8, 4, and 4. None of these are going to add to negative 7 or 7. So I'm going to use a quadratic formula to see if there are any other factors that I'm not thinking of. And when I write my quadratic formula, I have minus b, which is minus 7, plus or minus the square root of b squared, which is minus 7 squared, 49, minus 4 times a, which is 1, times c, 16 gives me 64. And I see my problem right away because 49 minus 64 is a negative value, negative 15. If I have a negative value as a discriminant, I know that I have only imaginary solutions here. So I have no real solutions for this particular equation. All right, last problem. Determine whether the given x value is a solution of the equation. Now I want to substitute 1 in for x in this equation. I have 4 over 2 times 1 minus 3 is equal to 8 over 2 times 1. 4 over 2 minus 3 gives me 4 over minus 1 is equal to 8 over 2. Or I can rewrite this as minus 4 is equal to 4. Well, minus 4 is not equal to 4, so I see that 1 is not a solution of the given equation. That's it for Aughton Math. If you've lost us or lost me in any of this process, go back and relearn Chapter 8.6 in Solving Rational Equations. We'll go through a couple different methods to solve rational equations. I believe there are 3 of them, and get you a little bit more comfortable in handling these practice problems.